Lesson 7, accelerated motion. So we've been dealing with a bit of acceleration so far, but we're going to get into the theory behind a lot of it now. So from here on in, we're going to be talking pretty much about instantaneous speed, and more particularly, we're going to be talking about instantaneous velocity because now our graphs are going to be our, if this was position time, they're going to be curved now, right? So we need to be talking about, if we're talking about velocity, it needs to be at any particular point on that graph, right? Making those tangent line slopes. Um, because we can't really talk about average velocity anymore because we're accelerating, right? We have accelerated motion. So, acceleration. Acceleration is the word used to refer to a rate of change of velocity. So, acceleration is just changing velocity over time. And it's really important that you don't mix up velocity and acceleration because that's a common one to mix up. There has to be a changing velocity for something to be accelerating. So just like velocity though, it's a rate. So they're both rates. So back to our velocity formula, we had change in distance over time. Now acceleration, we're just going to be talking about change in velocity over time. Like I said before, just don't be careful not to confuse acceleration with velocity. That's the big idea of this lesson. So to derive the accepted formula or equation for acceleration, and just so you know, derive just means to like figure out the formula. Um, all we have to do is we know it's going to be change in velocity, right? And all we're going to do is just replace that change in velocity with v2 minus v1. Just our v final minus our v initial. And you'll see that written often in physics too, where it could be v2 minus v1. It could also be vf minus vi. Just different ways of writing it. Okay, so then this is our formula, and you should have this formula on your formula sheet. It might be VF and VI though instead. And then it's still change in time in the bottom, but we just, we usually call time 1. We call that 0, so it ends up just being easier to write it this way. So now just to give you an idea of what acceleration is, let's look at an example. So consider this car, and it accelerates from 0 to 80 kilometers an hour in 10 seconds. So we can calculate the acceleration here. So we can say, okay, V2 was 80 kilometers an hour. V1 was 0. It started from rest. And that's going to be over 10 seconds. So our acceleration here is going to be 8 kilometers per hour per second. And this doesn't look like we've been writing acceleration the little bit we've done it, meters per second squared, right? This is still correct. It's just a little bit different so far. But if we think about what this means, so let's just stop for a sec. The acceleration is going to be 8 kilometers per second. This means that on average, the velocity changes by 8 kilometers an hour each second. So that means after 1 second, the car's velocity will be 8 kilometers an hour. So that's how fast it'll be going. After 2 seconds, it'll be going 8 kilometers an hour faster than that, so 16 kilometers an hour. At 3, it would be 24. So it just goes on like that. So notice that because acceleration is a rate of a rate, there's going to be 2 pers. And when I mean like kilometers per hour per second, right? And 2 units associated with, I lost myself here. There are 2 pers and 2 time units associated with acceleration. If we change kilometers per hour to meters per second, so we just change kilometers per hour, remember you just divide by 3.6 to get to 22 meters per second, then the acceleration becomes 22 meters per second over 10 meters per second. So we got 2.2 meters per second. And we can rewrite that as 2.2 meters per second squared. So I'd like you guys to just pause the video and read through this. This part here is interesting because it's going to come up again in our circular motion unit. For now, don't get too confused by it, but it is going to be important later on. All right, so the major conceptual difficulty in understanding acceleration is that people confuse acceleration, the rate that velocity changes, with the direction that an object is moving at a particular instant. And I'm gonna turn my video or the camera around either way, so you can kind of I'm gonna act this out so you can maybe understand this a bit better. Okay. So what I mean by that is that let's say that I was speeding up in this direction. So I'm going to be walking this way, and I'm going to just go quicker and quicker and quicker that way. Probably went into the screen there. It probably makes sense to you to say, okay, well that's positive acceleration. I'm speeding up and I'm going to the right. But here's where people get this wrong. Let's say that I'm walking this way again, but I'm slowing down. So I'm coming this way, and I'm getting slower and slower and slower and slower. So going like fast and then coming to a stop. Well, some people think, well, I'm moving to the right, so it's positive acceleration. But it's actually negative acceleration. What's happening is that I'm coming this way, and the way I like to think about it is if you had like an elastic band tied to your back. So I had like a bungee cord attached to my back. So I'm walking this way. I come to a stop, and then the bungee cord eventually would pull me back this way. So the acceleration the entire time was that direction. I've got like a bungee cord attached to my back. So it's whatever way is pushing you. So let's say I turned around though and I went this direction. So what direction or what would my acceleration be if I was speeding up in this direction? So I'm gonna go, start off not moving and then go quicker and quicker and quicker this way. Well, you can kind of think about the bungee cord thing again. It's like pulling me this way. I got some kind of force pulling me that way. So the acceleration the entire time was this direction, right? So it's going to be a negative acceleration. Even though I'm speeding up to the left. It's a negative acceleration because I'm being like pulled to the left. Okay, so now let's say that I'm slowing down in this direction. So I'm going to walk this way and I'm coming to a stop. Well, again, if you think about like the bungee cord thing tied to my back, I've got like a bungee cord where it comes, it brings me to a stop, and then I would eventually keep going this way again, and I'm gonna go to the right. So even though I'm slowing down going this way, that's a positive acceleration. So hopefully you kind of have that straight in your mind. That one kind of messes with people's heads. So if you need to, watch this part of the video again to see if you can get a good grasp on what that means. But I think about it as whatever way is like pulling me. So if you left the thing long enough, like so if I came to a stop this way and then kept on, going back again, eventually I'd be going to the right, so it's positive. But if I was speeding up this way, I'm going to keep speeding up forever. So I'm going to keep going to the left, so it's negative acceleration. So now looking back at some of these examples, they're going to be really just plugging in numbers into our new formula. So we've only got two formulas now, so it's not too bad. So this one says an object traveling at 40 meters per second increases its speed to 100 meters per second in 4 seconds. What was the acceleration of the object? So what I'd like you to do again, though, is write down everything that you know. Acceleration is the one that we don't, so I put a little question mark there. And then just plug in as you go. So in place of V2, we're going to have 100. In place of V1, 40. And then you end up with positive 15 meters per second squared. This one says an object traveling at 300 kilometers an hour slows to 40 kilometers an hour in 5 minutes. What is the acceleration? Normally, this would really stand out to me that this says minutes and my velocity was in kilometers an hour. But it doesn't really matter. It says there's no unit specified here, so let's just keep it in minutes. It still works. So we plug in our formula again. We got 40 kilometers an hour minus 300 kilometers an hour over 5 minutes. This is still right. It's just going to be negative 52 kilometers per hour per minute. It's just not, a kind of a strange way of thinking about it. I have no conception about, what, looking at that number, I wouldn't know what that means because I'm not used to thinking in kilometers per hour per minute, but it is technically right. So number 3 says an object traveling at 60 meters per second accelerates at 5 meters per second squared. If the final speed becomes 100 meters per second, how long was the object being accelerated? So we're getting to the point now where we probably want to make sure that we understand everything. A good tactic here, a good technique would be to highlight these things if you have a highlighter or underline and just know what they are. So this one's going to be V1. I know this one right from the units. It says meters per second squared. That's acceleration. It has to be. And it's going to go to 100 meters per second. So that's got to be our V2. And it says how long. So that's a key word for time. So now we can fill those things in that we know it. We start with our formula. In this case, though, we have to rearrange our formula. So we multiply both sides of the equation by t, divided both sides by a, and rearranged it to look like this. Notice that I was working down, right? When you manipulate formulas. Then plug in the numbers, and we end up with 8 seconds. Now, number 4, we're going to introduce negatives and positives. So it says an object traveling west at 40 meters per second experiences acceleration of 5 meters per second east for 5 seconds. Really, the west and the east, we can just make that positive and negative. So remember on our little chart thing, west and east. East is positive, and we call west negative. So we just have to do accordingly. So velocity 1 was going west, so it's negative 40 meters per second. Velocity 2 was the one we're looking for. Time is 5 seconds, and acceleration is going east, so it's positive. Start out with your formula. Rearrange your formula, just like we did. I think we even did exactly this one in an earlier video. Solve for V2 or VF, as it might be written on your formula sheet. And you get negative 15 meters per second. So remember, negative means west, so we can say 15 meters per second to the west. So I'm going to end this video here, and we're going to talk about acceleration due to gravity in the next video.